the channel. Now right here in this video, we want to evaluate the piecewise function when x is equal to some different values. Alright? Now you know that the piecewise function is let's say a function that contains two or more different equations defined over a specified domain. So here we have a piecewise function f of x to be equal to two different expressions right there, x over x squared minus 2 and 1 over x minus 1 plus 1 over 2. Now the first one is defined, is said to be, the domain is said to be when x is less than or equal to 1. Well, this may not really mean the general domain, it's just specifically giving you the value for which we will use this function. And right here is the same thing. You say we make use of this expression right here when x is greater than 1. So the question now is, you should evaluate this function if x is equal to 0. So a situation where x is equal to 0, we're going to use the piecewise function f of x, but the two expressions right there doesn't work for the two expressions right there. The two of them doesn't work. It's only one of them that works because of the domains of x listed here. The first expression will work if x is less than or equal to 1. So the second is if x is greater than 1. So look at this value of x, 0. Is 0 greater than 1? No. But 0 is less than 1. So we're going to make use of this because this satisfies this in blue. Alright? So we go ahead and make use of this expression right there. We have it to be x. We have it to be x over x squared minus 2. So when x is equal to 0, we're going to have 0 divided by 0 squared, that is 0 minus 2. Well, since the denominator is not 0 and the numerator is 0, therefore the result is equal to 0. And that's it, right? Now again, for the second one, if x is equal to 1, well, we just go ahead to the piecewise function and we look at the two domains of x right here. The first is said to be when x is less than or equal to 1, and the second is when x is greater than 1. So right here we see x is less than or equal to 1. So if it is equal to 1, we're going to make use of this, alright? Here it's just strictly greater than 1, it's not 1. So here we just make use of still the first one. We have it to be x divided by x squared minus 2. So when x is equal to 1, we're going to have 1 in place of x divided by 1 squared like this, and 1 squared is just 1 minus 2. Okay, so we have it to be that, well, at the top we just have the 1, and at the bottom we have negative 1. So 1 divided by negative 1, the result is just negative 1. Like that. Over to the next one. It's pretty simple, right? We just check for 2. Well, for the first expression, x should be less than or equal to 1, but 2 is greater than 1. So 2 is greater than 1. When x is 2, 2 is greater than 1. So we just make use of this. And again, we just go ahead and substitute. We have first of all x minus 1 plus 1 over 2. So when x is equal to 2, we're going to have 1 divided by 2 minus 1 plus 1 over 2. This is 2 in blue. Okay, so from here, the denominator is just going to be 1. So we have it to be 1 over 1. 1 over 1, that is 1, plus 1 over 2. Well, we can just do a simple simplifications right here. We just have it 1 plus half. 1 plus half, that is 1 plus 0.5. That is going to be 1.5. And 1.5 is something as saying divide 3 things into 2 equal places. That is equals to 3 over 2. And this is it. Okay, this was a pretty simple function. Alright, so thanks for watching this video. Please subscribe to this channel.